Hey everyone, this is Data 620 Project 3 name gender classifier. The group consists of Farhad Akbar, Adam Douglas, and myself, Soumya Ghosh. In this project, we are supposed to test out classifiers like decision tree and maximum entropy, etc., by taking the names corpus under NLTK and predicting the gender um, based on the names that we have. So we start off by importing the necessary libraries for our work, and we uploaded the names from male.txt and female.txt, the two files, and we converted all the names to lowercases and stripped off any empty characters, etc., that might be present as part of the initial cleansing. What we also did is if a set of names appeared both in male and female label data, we excluded them because we thought it might have an impact in the overall accuracy of the prediction. Um, and then we decided to create a bunch of features like the length of the name, first letter, last letter, whether the first or last letter is a vowel, and the list of vowels and consonants along with their counts in each name. We also created bigrams and trigrams that are present in the name and the syllables. Um, we also kind of looked at the bigrams and diagrams and took a quick count of each one of them across male and female corpus. Um, and we started off the data exploration just by looking at if there are some dominant features, like for example we can see the length of the average length of the female names are longer than male, and also there are 72% of the female names that ends with a vowel as the last letter. um, then we did a quick set of visuals of the first letter and last letter in the name, and we also did this analysis of first and last letter by gender, and based on the plots we can see that first and last letter could be pretty good predictors for gender. Then we did box plot for the length, vowel count, consonant count, and syllables. Based on the distribution, it looks like the length of the name, vowel, and consonant count are pretty even for male and female with few outliers. So it looks like these three predictors, length, vowel, and consonant count, may not be as strong as a predictor, although syllables seems like a good predictor because we can see the female syllables are pretty widely distributed, whereas male distribution is pretty narrow with few outliers. But we also did the bar plot for both male and female for all those predictors, and I think the results are pretty much the same what we got with the box plot. Then we start off with a decision tree classifier, and we follow a kitchen sink approach where in the first model all the basic features that we decided to use, we are gonna stick to all those features and see what level of accuracy we get. We did the data preparation, the data set and the test, and then we have split up the data set into train and dev test um, samples. We apply the decision tree kitchen sink classifier, and we get a accuracy of 62%, which is not too bad for the first attempt. But we conducted a error analysis to identify how to improve the labeling, and looking at the errors, it didn't reveal too much of an obvious pattern. Although we read in the textbook that typically the last two letters is a good indicator, so we refined our in the second model We defined our list of predictors and added last two um, as as a predictor, and we took out the length of the name and the vowel and consonant count, because based on our original analysis, it doesn't look like they're gonna add much value as predictor. So with this, we resampled the dev test set, and we applied the second model, and unfortunately we get lower accuracy of 54%. So we again conducted error analysis to see if there is anything obvious that we may have to do in order to refine our predictors. Um, Having both first the last letter and the last two letters as a feature may not be working to our benefit. So we also looked at the pseudocode, and looking at the pseudocode, we could see that consonants feature was the most influential in our data set. But since there are so few names, that we'll have matching list of consonants. This would be overfitting and probably not a good. It's not a good accuracy score that we can get. So we decided to refine our decision tree features, and we kept just the first letter, you know, with our first or last letter of vowel, and only two last two letters in the model. We reshuffled the dev test data set, and this time around we get an accuracy of 73%, which is slightly better than what we got initially. We conduct an error analysis, and from the error analysis we see another potential feature. Apparently there are many female names ending in ELLE. Creating a boolean for this may improve our results. We also looked at the pseudocode, and looking at the pseudocode we can see that um, we still never go past the two levels of nested if statements, but now the last two characters is the most relevant feature, as we can see, with the first letter as the most frequent feature in the second depth level of the tree. So we defined our predictors, and this time around we decided to use last three letters in the name as opposed to last two, and we reshuffled the data, sample data, and applied the model, and this time we got a slightly lower accuracy of 65%. So changing the last two to last three reduced the accuracy. So our previous model still seems to be our best model so far. um, so we quickly applied the model, all four models that we have tested so far, on the test data set, and apparently the last one, with the last three letters included in the feature set, generated the best accuracy. So the fourth model relied almost exclusively on the last three letters, and apparently there are patterns in the ending trigram that repeated often enough that it turned out to be a good predictor, as opposed to what we saw during the training and validation phase. Then we decided to go with the maximum entropy classifier. Again, we started with a kitchen sink approach, where we calculated all our base predictors that we did in the previous occasion, and and we decided to divide the test and training data set into multiple sets, and we applied the maximum entropy classifier model on all the sample data sets, and we got a range of 77 to 81% accuracy. We did error analysis to further refine the model, and based on the observation, um, we see that there are a lot of names which are actually female, and we incorrectly guess them as male, um, and vice versa. So we continued our analysis for the first letter count errors, first letter vowel count errors, last letter count errors, etc., etc. And looks like that we find that names that are actually male that were guessed incorrectly often end in E. That is an interesting observation. They're also likely to contain an A and or an E. And then we we continued our analysis that females are much more likely to have an A and oblique or an E in their name than males. So it is not surprising that males with these vowels in their name, we are guessing them as female names. So what we decided to do is, use we use the suffix to feature, which is the last two letters, and see we wanted to see if it improves accuracy, like they did in the textbook analysis that was done. Um, so we applied the model, and we got a fairly good accuracy, like from 80% on two occasions. We got 80% and 82%. Um, so in some cases we saw an improvement. Um, so we wanted to try out, instead of using last two letters, if we include second to last letter as one of our features. So we added that next to last letter is a new feature that we tried, and we again applied the model. We got similar result. There's not much of an improvement in accuracy after adding this new feature. In some cases it did, in some cases it didn't. So we wanted to check the final model evaluation. um, so instead of, because we didn't get significant improvement in the model accuracy by adding those new features, we decided to um, go with our base set of predictors, and we applied that in the data, and we got 80 to 82% accuracy, using all the base predictors that we have chosen. So that's it. Thank you.